Heather D'Angelo, editor of NOW.SPACE, and I'm here at NASA Ames Research Center to speak with Daniel Faber, CEO of Deep Space Industries, about the exciting new world of asteroid mining. Mining asteroids sounds like the stuff of science fiction, but unbelievably, Deep Space Industries says that it can be done. So whenever I meet someone who is making the stuff of science fiction a reality, I always have to ask with the question, did you watch a lot of Star Trek as a kid?
I actually didn't watch a lot of Star Trek, but I had a lot of friends that did. So I think I can recite more Star Trek than the average Joe, but only because I absorbed it by osmosis.
How did you get into asteroid mining?
Well, actually, I got to university and didn't know what I was going to do, and decided that I wanted to do something positive for the world. And the best thing we could do was to get people off Earth. And that would address existential risks, which, any risks to our existence are very important to look at. And so I decided that getting people off Earth was something that was both achievable and very, very useful. And so I made a list of all the things that could pay for the first permanent job in orbit, because I was in Australia and there's no space agency. So that list was very short, and it contained space tourism, space-based solar power, and mining. And quickly realized that space-based solar power really needs mining to get the costs of the materials down. And I couldn't see myself as a tour operator. So 18 years later, here I am.
So what kind of career path did you take to get to this point?
So when I was at university and decided this is where I wanted to go, I tried to read as much as I could and start with what I could start with, which was, why are spacecraft so expensive? Let's build one and find out. So I started doing that at university and undergraduate, and then managed to get a job building small high-performance spacecraft. And we sort of managed to, I got very lucky. I was in teams that were really pushing the boundaries of what small spacecraft could do. And from there I took a few different jobs. I was working building avionics for inflatable space station prototypes. I was did a lot of sort of cutting-edge space stuff, and then set up a company to do instrumentation for the mining industry. And that took me into nuclear physics. I built desktop nuclear fusion reactors and fast neutron cameras, came back to the space industry, and we did high-speed internet for Antarctica. I managed to go to Antarctica for a while. Then CubeSats had been invented, these really small spacecraft that sort of a new paradigm. So I went to Europe and worked on CubeSats for a while. And then sort of finally brought all that together, and there were a group of people who were talking about asteroid mining and had a lot more experience than even I did on the geology side and that kind of thing. And so we all got together and founded Deep Space Industries.
So then how long has asteroid mining been a part of the conversation?
It depends who you ask.
Okay.
Our chief scientist wrote the book on space resources, on asteroid resources, back in the early 80s. He's now written many editions of that book. We recently published Asteroid Mining 101, which is his latest book. So he's been talking about and popularizing this and looking at the business cases and the like for 30, 40 years. Other members of our team have done similar things. One of our directors wrote the first work looking at net present value economics and how that works with orbital mechanics. And so he's also developed some substantial ideas there. All the way through the team, we've been looking at this space for a long time, and so bringing it together into the company, the real thing was, can we make a business of this? Is it ready? And what we saw a few years back was that with the miniaturization of technology, you could do the exploration and the early phases a lot more cost effectively. With the potential for reduced launch costs, it reduced the capital cost as well. And so there are a lot of things that were converging, as well as our own understanding, the maturity of the science and geology. All of these things meant that now we have a chance to close the business case. So we did some economic studies, we did a lot of preparatory work, and then decided, okay.
Why asteroids?
So here's one important thing to realize. We're not trying to bring material back to Earth. We're bringing everything to Earth orbit. We're going to sell and provide services in Earth orbit. On the Earth, there's a lot of metals being mined already. There's an active market, and there's a price being set in that market. And we considered the economics for asteroid mining and other sources of in-space materials, and we couldn't close the economics bringing anything back to the Earth. However, in space, it costs so much to get anything off the ground. It's currently about $5 million per ton, sometimes $10 or $20 million per ton, depending on where you want to go to. And so if we can provide that utility at a lower price, then we have a business and we can help expand the economics in space. So with that, with that start, this is the market that we want to provide, supply into, and we want to create and grow, then where is the best source for those materials? Asteroids happen to have a high abundance of materials of interest that are easy to access and bring back into that orbit and easy to process. And so all of those things and our understanding of the geology, because we have the meteorite samples, also meant that we have a maturity in the science and the geology. So that gave us a lot of confidence that the asteroids are much more prospective and that the market is in Earth orbit.
What kind of resources are in the asteroids?
So interestingly, the thing that we're probably going to go after is water.
Yeah.
Water it's like oil, I guess, for the for the space industry. You can use water to turn into hydrogen and oxygen for rocket fuel. You can turn it into other rocket fuels as well. You can breathe the oxygen if you split it. You can do a lot of things with water. So that's going to be one of our first things. And if you go out to an asteroid with a thruster system, it has to use the material that's on the asteroid to come back. Otherwise, the rocket equation says you're really not going to bring very much back. So we need to use that. So the first thing we'll do is make propellant out of the asteroid using water that we can then bring back large amounts of material. And then we go for subsequent things. There are hydrocarbons. We can make lubricants and 3D printer feedstocks and various things. There's nickel and iron, and you can then start thinking about 3D printing large structures, solar concentrators, radio reflectors, all those types of products.
Oh, are you kind of imagining this as like a gas station in space?
That's a great description. Yeah, totally. This is the gas station and the hardware store. That's right. So you've got a business serving customers on the ground. You really want to enhance that capability and make everyone's lives better. You need materials, and if they cost $5-10 million per ton, it really constrains your business.
So can you imagine that this will allow spacecraft to go farther into the solar system?
Yeah, absolutely. So if you want to go further into the solar system, you need a lot of propellant. The rocket equation is quite demanding.
Right.
If you have that propellant brought back from asteroids and then in abundance, you can really load up a much larger mass. So if you want to go to Mars and you want to take enough things with you to live there, then it really pays to have a source of propellant in orbit. So you've just got to lift things from the ground, and then we can take them the rest of the way.
Okay.
So those kind of activities, NASA wants to go out to explore deep space and the edge of the solar system. Everyone wants to move larger masses around to be able to do more science, more exploration, more interesting things. Yeah, everyone wants propellant. It's the enabler.
What are the limitations right now of the technology, or how do you plan to get to the asteroid?
So there's been a lot of robotic spacecraft that have gone out to asteroids, either flown by them, taking pictures, or gone into orbit on them, even landed on them. The European Rosetta mission carried the Philae lander, and it landed on a comet, which is very similar to an asteroid. In fact, a number of the asteroids are thought to be comets that have just stopped having a tail. They stopped outgassing, and they're kind of dry on the surface. So that was a great example when they touched down and got a lot of measurements. There's a NASA mission near that touched down on asteroid Eros. There's just a lot of missions that have gone out. So we're learning all the time more and more about the geology of the asteroids. But so when we think about going out there, we've already got a lot of this information. But also, the asteroids have come to us. We have a lot of meteorite samples from a range of different asteroids. And when we look at those, and there's a few here. So this one fell in Namibia 10 or 20,000 years ago.
Wow.
People have gone out and picked up about 20 tons of this particular meteorite fall. And it's made of nickel iron, so it's all shiny on one side where we've polished it, so you can see the crystal structures. But so this tells us about one type. And we can match a reflection from this. If you put it in sunlight, it has a spectra. And so there's more red and less blue and those kind of things. We can match that to what we see on the asteroids, which means that their surface, at least their surface, is made of this material. Or then we can match it to a different one. So here's a rocky meteorite, and we can match the reflection spectrum of this to a different class of asteroids. So all of the asteroids, I think that there are now about 19 classes of meteorites, and we can match those to the spectra from the asteroids. So we know a lot about the mineralogy and the things that are there that we should expect.
Okay, so yeah, it's not like you're shooting in the dark here. Like if you pick out an asteroid that you want to visit, you know what it's going to be made of by the time you show up.
That's right, though we do have to verify it. And geology and mining and mineral exploration, there's a process that you go through to verify your hypothesis. You come up with a model of what you expect to be there, you go and check it. Anywhere that wasn't quite fitting, you adjust your model, you go and check that until you have sufficient confidence that you can spend the money needed to go and actually extract that material.
Do we know how much water an asteroid holds?
Well, we know how much some of the meteorites hold, and we have the reflection spectrum match. So that gives us an indication that those classes of asteroids have 10 to 20% water. Some of the comets that are extinct, we don't have comet samples because anything coming through the atmosphere, they're dirty snowballs, so
right.
they disappear. But because the Philae lander, we now have a very good idea of what's there. We've done a lot of calculations on those. They can be as much as 60% water, maybe even 80%. So when we go out there and think, what is the percentage concentration of these minerals? Somewhere between 20 and 60% for certain classes of asteroids.
And how do you plan to get to the asteroids?
We do it the same way everybody else does it. You sit on the end of a rocket and you burn until you're going in the right direction. But we have to do that, then we have to match course with the asteroid and get into orbit around the asteroid. And the gravity is very low, so landing is a bit of a misnomer. You sort of dock to it rather than land on it because the gravity is so low. And then you need to sort of clamp on and do some extraction work and test work and things. So yeah, we'll do that, and then of course come off, use the propellant that we've manufactured out of the asteroid material to come back to an Earth orbit.
Is it legal to go and take resources from asteroids?
That's a really interesting question. At the moment, there's a treaty amongst most of the nations in the world called the NOW.SPACE Treaty, where they've all agreed to cooperate on a lot of things in space. So that's sort of the founding document for the regulatory environment. But it doesn't explicitly say, go forth and mine asteroids. It doesn't explicitly say you can't. Now, under international law, that usually means if it's not forbidden, it's allowed, but it does say that each nation has to regulate the activities of their individuals and companies. So the US just last year passed a law that said explicitly asteroid companies that go and extract, or individuals that go and extract material from an asteroid, can own that material. So that's the first time that any country has actually had that as a law on the books. Now, since then, Luxembourg have come out and said that they're interested in doing a similar type of law and promoting an industry there. The UAE are rumoured to have something in preparation, and other countries are looking at it as well. So I think because we're at this tipping point where it's now becoming feasible and there are companies looking at it in a serious discussion, the regulators are starting to realise, we need a suitable regulatory environment if we want our companies to be able to play in this space. So the answer is, well, the regulations are not written, but the legislation in the US says this is, you go forth and make money, improve the world, use the resources.
For those who don't know, what is the new space industry?
So the new space industry is it's a name that's thrown around a lot, new space, and I guess it contrasts to old space, which is just traditional space. It's a bit of a new way of thinking and being a little more entrepreneurial. And the space industry was created in the 60s with the Apollo program and a lot of activity there. There's been a lot of defense activity. These are government spheres. In the 80s, the commercial satellites started to get built around telecommunications, and they were built to a similar model that the government satellites were. These are big satellites. They get economies of scale, and substantial business now, to the point where more than 50%, I think it's something like 60 or 70% of the space industry is commercial. When you look at all the applications that those satellites drive, so it's already commercial is already a large part of the industry, but the new space is trying to bring an entrepreneurial spirit to that and say, let's innovate on this. What are the new businesses we can start up? Let's unleash the entrepreneurs. How can we do a lot more activity? And that's been enabled by the miniaturization of spacecraft, which have lowered the barrier to entry. So now it's possible with much less capital to get into the game and start building up a reputation and building up assets and finding customers and proving things out. So a lot of companies are really leveraging off that, which has been it's been a really exciting time in the industry. So that's what new space is. It's just the entrepreneurial approach. And all of the big space, the traditional aerospace companies, they're also looking at this. They're also being entrepreneurial. So it's a bit of a misnomer, as most categorizations are, but that's the general feel.
What are you most excited about, besides obviously asteroid mining?
The future. And it's pretty amazing. We now have communicators that are frankly better than what Star Trek had. We now have so much that's pretty exciting that's happening. The future is going to be pretty amazing.
That's very quiet.
But who knows? Everything I predict about the future, some entrepreneur is going to come along and challenge.
That is always the way. Well, it was wonderful speaking with you. This was fascinating.
This has been great. Thanks. Yes. We should do it again.
I would love that. Thank you so much, and best of luck with all of this.
Thank you. Appreciate it.